So the question is, a random sample size n is to be taken from a large population having a standard deviation of 1. The sample size is to be determined so that there will be a 0.05 risk probability of exceeding a 0.1 inch tolerance error in using the sample mean to estimate m. Which of the following values is nearest the required sample size? So this one requires you to use the sample size formula. I don't know if you have it. You know the sample size, how to calculate the sample size? That is n equals z squared times sigma squared over e squared. We have that?
Can you say that one more time at me? Let's see.
Sample size, where is it?
I have that, the reference is on section 8, page 35 in the textbook.
Yeah, my text is 54, but yours might be a little bit different.
Okay.
So n equals z squared times sigma squared over e squared. Very good. So here, so if you look at the z, it says 0.05, right? So it's the risk probability is 0.05, which means 90.
So that's what. So z is 0.05, and that means risk probability.
No, not g is not 0.05. So that means 95% of confidence level.
Okay.
Right. So when it's 95% of confidence level, you have to take a look at the z score. Right. So I don't know if you remember how to read the z score. So at that time, go to z score table, and when z is 0.95, I wished I brought my tablet so that I can show you. Right. But maybe I will use Excel. How about that?
Okay. I love Excel.
I will use Excel. My screen. Okay, so z score. So the 0.95 is your probability. So then your z score in this case is norm standard inverse point. Okay, so that's 0.164, right? However, in this case, okay, so that's a little bit difficult to explain, but let me try. Right here. I wished I had this. Okay. So here's a z function, z distribution, and here's a 0. Okay. When it is 5%, what that means is we have rejection area in both cases. It's a two-tailed test. And this rejection area is going to be 0.05, which is 5% of risk level in this question, divided by 2. The reason why I divided by 2 is because this is two-tailed test. There are two areas where it can be rejected. It can be greater than this area or less than this area. So the tails are in both sides of the distribution. So
Is
0.05,
Is it always that way?
mostly, yeah. If it does not say it's greater than something or less than something, at the time it's a one-tail test, as you learn in hypothesis testing. But if it is not mentioned at all, then there's two possibilities. It can be greater than something or less than something. So
Okay.
in that case, you have to divide 0.05 divided by 2 gives you 0.025, right?
Okay.
And that's here, this is also 0.025. 0.025, right? So to find this number, we have to look up either the Z table or from here to here. So let me change the color. So from here to there. In Excel, if you're looking at only this area, so what is the Z value? That's what we are looking at. Right? That's what we are looking at. And we find that this is Z equals, that value equals, we can calculate norm
S inverse.
and then dot inverse function you use, and then you put here from this shaded area by red is 1 minus 0.025, right? Which is this equals 0.975. Right? So if I go back to now Excel here, that's why I used norm dot s dot inverse function and 0.975, or I can say norm dot s dot inverse of 1 minus 0.025 will do the same thing. Right? So this is 0.96. So usually, if you read this function, what is this? Then it's going to be 1.96. That's how you find the Z value.
Okay.
So Z is 1.96. Okay, so the formula is N equals Z squared. So I'm going to use Z squared times sigma squared divided by E squared. That's the function. So now N equals, we found that that's 1.96 and multiply squared times. Now sigma is here given as, it says, what is sigma here? It says a standard deviation of 1 inch, right? So standard deviation is given as 1 inch here in this question, squared, divided by E squared. E is margin, right? Margin of error, the desired interval, and it says it's a 0.1 inch of margin of error or interval it has. So 0.1 inch and squared. And let's run it. So I'm going to just delete that. And 384.6.
So sigma means standard deviation and E means error, right?
Yeah, E means error, yes. Or the desired interval.
Okay.